Any audio now? Can people hear me at all now? Great. Okay, my mic decided not to want to connect today for some reason. All kinds of good things happening. My camera also doesn't work today. I don't know. Everything just worked first time. Last couple times I tried it. Okay. There we go. Look, everything's just going crazy on me today. All right. My computer's not having a great day. That's okay. We are started. We're a couple of minutes late, and I apologize for that. I had a meeting right before this, so usually it takes me a little while to get everything kind of set up so I can do this. It's fairly quiet. Yeah, I can pump that up a little bit. There. Is that a little bit louder? I had to dampen the audio quite a bit when I had the mic right up against me. Okay, good. Please continue to let me know in the chat if this experience is bad, and I'll do what I can from here. Yeah, this was usually such a good thing. Well, don't worry, I'll get it figured out. It seems like these two pieces are not talking to each other. Nevertheless, I don't think you care about that. You're here for chemistry, and we are towards the end of the unit on toxins, and once we're done the unit on toxins, we're going to start the next unit, so we only have like a tiny bit left. We learned quite a bit already, though. You know, we learned about LD50, which is acute toxicity. We learned about how to measure chronic toxicity, which was NOAEL, which we can translate that into something called an ADI, which is our acceptable daily intake. So you can work out for normal substances that you might be coming into contact with on a daily basis, what's a safe level for you to consume each day without expecting to show any sort of chronic effects. Okay. We looked at a couple of examples. We looked specifically at the case of mercury, and we learned there that mercury comes in lots of different forms. And mercury in one form does not pose the same risks to us as mercury in another form might pose. So what that means is, you know, just because something contains a form of a compound doesn't mean at all that that compound is necessarily dangerous, or for that matter, beneficial. So take something that we need in our diet, something like iron. Different sources of iron are absorbed by the body at to different extents. It depends what else we might eat when we're eating that source of iron. And for that reason, just because something contains iron doesn't necessarily mean that it's what our body is going to need at that particular point in time. Reminds me actually of a story in chemistry. There's this drug company that produced a drug that as part of the process, it would come out as a white powder when they were finished. And this drug was like a blockbuster drug. Like they were selling like $5 to $10 million worth of this drug every week. And they had this giant factory in New Jersey that was producing it. And they do these giant batches of like several tons of the drug in one go. And what had happened was on like the 85th batch or something like that, the chemical, instead of coming out in its normal white powder, formed these little crystals. And these crystals were like super insoluble. And if you ate the crystals, they wouldn't dissolve. They were not bioavailable. So the pills didn't do anything. They just ran right through you and out the other end. And they're like, well, okay, that sucks. We lost this batch. So they tried to do it again. And every batch they made after that point, they kept getting those crystals. They couldn't get the original formula to work anymore. And what they thought, what happens sometimes, if you have little, what are called seed crystals, little tiny crystals, they can cause more crystals to form. So they thought this factory was just contaminated with these little seed crystals, and they would never be able to really, because they're microscopic, they could never really clean the factory well enough to get the original form of this drug back. And what they actually ended up doing, their solution was to build a new factory in Italy. And when you think about it, if they're losing 10 million bucks a week by not being able to produce more of this drug, that justifies spending tens of millions of dollars to build a new factory somewhere else so you can continue making it again. So sure enough, they built the new factory. The first batch had all these crystals in it too. So bit of a waste for a new factory, but they went to figure out what the problem was, and they'd realized that they had some engineers and technicians travel from one factory to the other factory during the construction, and they think they may have carried some microscopic crystals with them in their clothing or in their hair or something like that. And they actually never solved the problem. They never were able to make the active form of that drug again. And so what they ended up doing is they were able to do some like completely different type of formulation, like chemically changed it so it was not quite the same, but so they developed a workaround, but they were never able to go back to that original recipe. It's just a very neat, stark example for me at least of how slightly changing the structure of something or the form of it, or it's even how it crystallizes, like what the geometry of the crystals are, can dramatically impact how that chemical can behave and can act. But that was really hopefully obvious from the mercury thing, where you can have the liquid mercury, which is very different than the mercury in fish, which is very different from the mercury that you find in vaccines, and so on and so on. There's many, many different forms that have each their own unique set of risks and benefits. I wanted to round this up. It's a pun there, because we're talking about Roundup. We're going to round out this unit, so I won't have to use that bad pun again, talking about glyphosate, which has been in the news a lot, and we might come back to this one later on. There's a bit of a unit on pesticides and herbicides where maybe we can go into more detail. But this is the #1 herbicide used in agriculture in the US and probably Canada too. It's produced by Monsanto, which is a company you may have heard of, and it's sprayed on weeds, and what it will do is it'll kill basically any weed. What it does is it tricks the plant into believing that its growing season is done. So you know how trees, naturally at the end of their growing season, the leaves will change color and drop, and they'll absorb the nutrients. This will trigger the same sort of biological response in plants and tells them time to give it up, and then they do. There's a lot being said about glyphosate toxicity, and the reason is because, first of all, it's used in tremendously large amounts, right? There's tons and tons of this stuff being used every day, and it's a synthetic chemical. It's not natural. So if you use this in your farming, you cannot claim to be an organic farmer, because this does not come from a natural source. But does that mean it's dangerous? Well, we can measure this stuff, right? LD50, 5,600 milligrams per kilogram of body weight, measured in rats. This is an extremely high LD50. Does extremely high LD50 mean very toxic or not very toxic? Yeah, not very toxic. Not very toxic at all. So this would be similar to most drugs, right? Which you take drugs. When I say drugs, I mean pharmaceuticals. I don't mean street drugs, right? So yeah, this was actually, I think, the same number as sulfamethoxazole, very close, which is a antibacterial drug we talked about in a previous class. In order to poison yourself acutely, right, to hit your LD50 of this, you need to drink 27 bottles of Roundup, which is a total of 20 liters of the solution, which is a total of almost 400 grams of glyphosate, assuming you weigh 70 kilograms. And I think 70 kilograms is just chosen as a potentially average weight for a human being. Chronic toxicity as well has also been measured in rats, and the NOAEL has been established to be 31 milligrams per kilogram of body weight. So this is telling you the long-term chronic impacts of this particular thing. It's saying rats can be fed 31 milligrams every day of this material, of this pesticide, for every kilogram that they weigh, and not experience any observable negative long-term side effects. And then they take that number, divide it by 100 to establish the acceptable daily intake for humans, which is 0.3 milligrams per kilogram of body weight. So if you weigh 70 kilograms, again, that same 154-pound person, which I'm well above that, that person can consume 22 milligrams of glyphosate every day and not exceed their ADI. And that means they could eat 100 times that and not exceed the NOAEL level set for rats, right? So that 100 10-fold margin of safety is built into that number. So 22 milligrams doesn't actually sound like a lot, right? Is it? Yeah, if you drank a bottle of this stuff, you'd hit your 22 milligrams pretty fast. But in terms of like pesticide residues on your food, is it very likely that you could poison yourself from glyphosate by, would the residues ever add up to anywhere near 22 milligrams? The answer is no. The science has been done, and what they've done is they've calculated sort of the worst case scenario diets, meaning if your diet was exclusively the foods that contain the highest amounts of glyphosate, you would come nowhere near still your ADI. You'd have to really try hard. Does that mean we don't have to worry about this? Well, maybe if you work spraying this and you're exposed to a lot through your job, or if you're in a production plant that makes this stuff, then these things may be of a real concern to you. Okay? But as a consumer, Health Canada actually has our backs. Health Canada is constantly doing testing on foods to make sure that we are below this. Yeah. All right. It came out in the journal Scientific American, this article, widely used herbicide linked to cancer. The World Health Organization's research arm declares glyphosate a probable carcinogen. So what does all this stuff mean then? I talked about ADI, and if you stay under that, you have nothing to worry about, and Health Canada's got our back. When this article, Scientific American, and this isn't exactly the Food Babe or some kind of sensationalized thing online, this is like a legitimate publication. It links this compound to cancer, and it's true. The World Health Organization declared glyphosate a probable carcinogen. The problem with declaring something a carcinogen is that puts it into one category or another category. It's a carcinogen or it's not. It doesn't tell you anything about the dose necessary to induce or increase your risk of cancer. And it also doesn't tell you by how much is your risk of cancer increased. So for example, we know smoking increases your risk of lung cancer. Will one cigarette increase your risk the same as if you smoke 10 cigarettes a day for the rest of your life? Well, clearly those two are different doses, different types of chronic exposure, very different impacts on your likelihood of developing cancer sometime down the line. So all these other agencies, in addition to the World Health Organization, and I'm not going to jump on the Republicans in the US complaining about the World Health Organization and pulling out, but these other agencies said glyphosate is unlikely to cause cancer in humans, including the EPA, Environmental Protection Agency, European Food Safety Authority, Health Canada, Food and Agriculture of the United Nations, et cetera, et cetera. All these groups are coming out and saying, well, you're calling it a carcinogen, but we don't see any evidence that this can increase the risk of cancer developing in human beings. So we have this disconnect, at least on the surface. If you look at this just blankly as a member of the general public without any expertise in regulations, regulatory committees, all these sorts of things, it's what you'd first probably gather is, well, they don't really know. There's debate. But it turns out there's not debate. When they call this thing a probable carcinogen, and these guys say it's unlikely to cause cancer in people, it sounds like they're talking about the same thing, but they're actually talking about two slightly different things. One is hazard and one is risk. Hazard means something has the potential to cause some negative effect on you. Risk is the likelihood that it will cause some negative thing to happen to you. And again, those two things sound similar, but a hazard is present. It doesn't imply any sort of a likelihood, your chances. An example is, let's say you go hiking. I don't know if anyone here has gone hiking at Cape Split before. I'm sure somebody has. Maybe everyone has. But maybe if you've done this hike, when you get to the very end, you arrive at the peak that kind of looks like this. So you're in that on that kind of treed area before those two little broken off parts there. There's a really steep cliff there. That cliff is a hazard, right? Does that mean it's dangerous for you to do this hike? Well, if you do the hike, you stay 100 feet from the edge at all times, the risk to you is extremely low. If you got on a unicycle and tried to cycle right around the rim, the risk to you is very high. The hazard doesn't change. The hazard, the cliff itself, is the same in both of those scenarios. So if you apply this to sort of a chemical thing, drinking alcohol, is that a hazard? Well, yes, drinking alcohol is a hazard because if you drink too much, you can poison yourself. Does that mean if you drank a spoonful of beer, you have a high risk? No, your risk of overdosing from alcohol is extremely low, although the hazard is the alcohol. The alcohol is itself, it's the same in any different scenario. So what we're talking about when we talk about cancer risk here is there a scenario where glyphosate could potentially pose a hazard such that, is there a way that you can interact with this substance in a way that could elevate your risk of developing some type of cancer? And the answer is yes. However, under ordinary exposure that humans would get through their diet or whatever, is this likely to actually cause cancer in anybody? And the answer to that, according to these agencies, is no. So these agencies are talking about risk. This agency is talking about hazard. So further to that, I'm going to skip ahead a little bit. By the way, here's an example. There was a story a couple of years ago of a hiker seriously injured doing this hike, falling off the edge of the cliff because her dog ran off the edge, and she went over after and was seriously injured. Surprisingly survived. Like, that's a really high cliff if you're ever there. So yeah, the risk is very high if you behave that way to that hazard. So it's a bit confusing, but it's a little bit muddled up. By the way, this is the WHO classification scale, and this is classifying substance according to hazard. 1 is carcinogenic to humans. We know this is true. There's very strong evidence suggesting that it increases your risk of cancer at some level of exposure. 2, probably, meaning there's reasonably good evidence. This scale isn't how badly it causes cancer or how much it increases your risk. It's just how firm we are in our knowledge that it can increase risk. 2B is possibly 3. We don't have enough information to say one way or the other. And 4 is probably not carcinogenic. And surprisingly, there's only one chemical substance known that's in category 4 where we know with certainty that it does not elevate your risk of getting cancer. And that's caprolactam, is the single compound that's deemed to be zero hazard for developing cancer. Now, they didn't test every single compound. Like, water probably isn't on this list, and water, your risk is pretty low. But if you look up at the top, level 1, carcinogenic to humans, these are all the things that we sort of know well can increase your risk of cancer. Tobacco, smoking, right? Plutonium, mustard gas, alcohol, sun. We know that too much sunlight increases your risk of getting skin cancer. Does that mean walking outside is like a really high risk activity? No, but laying out in the sun for hours on a regular basis is a high risk activity, right? So having residues of glyphosate on our food is kind of like going out for a walk in the sun. Whereas, I don't know, maybe drinking it out of the bottle might be the same as like going sunbathing. Look at the ones that are in the probably carcinogenic. This is the category 2A where we find glyphosate. Red meat. Yeah, we know with reasonable certainty that a diet that's high in red meat has elevated risks for developing certain kinds of cancer. Very hot beverages. So if you don't wait for your tea or coffee to cool down enough that does increase your risk. We know that with relatively good certainty. Does this mean this should be a major concern? Does it elevate your risk enough that we have to really be aware of the temperature of the liquids that we drink? Working as a hairdresser is another one. Working night shifts. So does that mean no one should work night shifts anymore? Well, things would fall apart pretty quick, especially if you got cancer and ended up in the hospital. I think you would be hoping there'd be people in the hospital working night shifts. So these categories, they're not really categorizing something according to how dangerous it is. They're categorizing it as to how well do we understand or how good is the evidence that this might have a link to cancer. And some of these, the evidence is very strong, like smoking. Other ones, kind of more towards the 2B and the 3, the evidence is very weak. And in the middle is 2A. It's like the evidence is, it's reasonably good, but certainly we could learn more. And that's where glyphosate is. So just because something gets categorized as a possible or probable carcinogen or a definite carcinogen doesn't mean we have to run for the hills screaming, right? Processed meats like bacon are in the group 1. Does that mean you should never eat bacon? Well, it probably means you shouldn't eat a pound of bacon a day. But does it mean that you can never have bacon? Well, no, right? It doesn't mean like, oh, I had bacon when I was 7, I'm going to get cancer either. It doesn't mean that, right? So we got to assess risk, because our whole life, we're always assessing risk. Every decision we make is a risk assessment. Everyone here who's decided to come to university, there was a risk. I mean, a financial risk to coming to university, right? You had to make that decision, and there's a risk benefit to everything that we do. Conclusions. All substances have acute and chronic effects. Magnitude of those effects, the risk it poses to us, depends strongly on the dose, route of exposure, and other things, right? Like the form of the compound and et cetera, et cetera. And your particular body type, your level of activity, your age, all these factors. There's lots and lots of factors, which is almost overwhelming because there's an overwhelming number of compounds that we come into contact with every day and an overwhelming number of confounding factors. And this is why we have organizations like Health Canada to provide guidance, because there's no way you could possibly keep on top of the literature for every known substance and its risk depending on your particular category of lifestyle or age, demographic, whatever it is. These acute and chronic effects are knowable. They can be measured. LD50 is measurable. NOAEL is measurable. So we can know what these things are. Use of anything has risk benefit. National, international agencies like Health Canada are generally quite trustworthy. And yeah, just detox diets and teas, etc. don't do anything. So yeah, stay away from those. Okay. I actually have one question. This is going to be our last question for this particular unit. Which discredited medical doctor played a large role in fueling the anti-vax movement by his fraudulent paper linking vaccines and autism? Andrew Wakefield, Dr. Oz, the Food Babe, or Dr. Phil? We do talk about Dr. Oz a little bit later on. Next unit, we get to complain about a few more people. Food Babe, I think maybe I ruled her out by my use of pronouns. I should be more vague my use here. All right, so this is it for this particular unit. What we're going to be doing is swapping over to the next unit now, which is going to build on some of these themes for sure. And as well, what we're going to be switching to is the next unit assignment. So unit assignment 1, I just want to be very, very clear and reemphasize this, and I sent an email to this effect already. But unit 1, the unit assignment is due a half hour ago. Yeah, so that's done. If you haven't done that, too bad. I think I checked though, and when I sent the email out, only 4 people hadn't completed it. The next one is going to be due a week from today. And I'm setting all of the due times to be 2:20 p.m., which sounds random, but it's like right before this class starts. So the idea is you'll have that done and then be fresh to start this next unit. The third one should be open right now, and this is going to be based on this unit that we're going to be starting. And this next unit that we're going to be starting is going to be good science versus bad science. So, you know, a little bit of the scientific method we're going to be talking about. It'll be looking at maybe case studies, a couple of examples, and maybe call a few people out at the same time. Nobody in this class, though. How are the online folks doing? Everyone's doing good? You can still hear me and see me okay? Wonderful. It's funny when I ask questions to the online because there's like a 10-second or 15-second delay, so I won't get an answer until well after I ask the question. Anyone know who this person is? Yeah? Yeah, that's Steve Jobs. And if you look in the background, you can see that Think. That was like the original poster for Apple. And so Steve Jobs is one of the two who co-founded Apple Computers with Steve Wozniak. And kind of an interesting story. Apple started out doing quite well. I think it started maybe in the 1970s, in the 1980s. And he got kicked out of his own company at one point. The board kicked him out. And then Apple started to do really poorly. Microsoft and PCs in general were almost the entire market. And Apple was sort of on the verge of collapse. And they brought back Steve Jobs, and then Apple roared back. And the first successful product that they brought back was the iPod. And the iPod, I remember the original generation. I remember what you had before then was really crappy. They had MP3 players. I remember that you could get MP3 players, but you could hold like 12 songs on the max. And then these came out that were like gigabytes. You could hold like every song you could imagine plus 10 times more on one of these things. And then they came in all the different generations. They had that click wheel to begin with, and they moved to the iPod Photo for a while, and then the iPod. What was the one that actually had the screen? It looks like a phone. Touch, yeah, iPod Touch. Then of course they switched into iPhones, and then iPads, and then AirPods, and everything that we have today. And now I believe they might be the number one company in terms of like market share, like stock value, so on. I don't know if Amazon might have overtaken them, but they're definitely in the top few. So it's one of it's either the most valuable company or one of the most valuable companies. And to put it in perspective, they have cash reserves that if they spent their cash reserves, they could buy all of Disney, like the entire company and everything Disney owns, which is itself a big company. They could just buy that with their cash reserves, still have cash left, and like not even have to give up any stock or anything like that. So yeah, they're a well-off company. He died in 2011. So this was him towards the end of his career, showing off, I think that's the MacBook Air. October 5th, 2011, this was the memo that went out among workers in Apple. CEO Tim Cook said, "Team, I have some very sad news to share with you. Steve passed away earlier today." So why did he die? Why did he pass away? A guy named Walter Isaacson wrote a biography of him after his death, which discussed his illness towards the end of his life and his eventual passing. He had pancreatic cancer. In fact, he had the only form of pancreatic cancer that is treatable. Many forms of pancreatic cancer, there's really no effective treatment for them, but there's a few types, and he was lucky enough, I mean, in retrospect, to have had one of the types that had a reasonable chance of success. His biographer says this, though: for 9 months, he refused to undergo surgery for his pancreatic cancer, a decision he later regretted as his health declined. So 9 months with an aggressive form of cancer is giving that cancer a real head start, right? And certainly he wasn't refusing to undergo surgery because he couldn't afford it. he had as much resources as any human being in this world could possibly expect to have in the, most advanced healthcare country probably in the world. And he decided he didn't want to. Instead, he tried a vegan diet, acupuncture, herbal remedies, and other treatments he found online, and even consulted a psychic. So, suffice it to say, these would all be considered non-traditional methods of treating a very aggressive disease like cancer, very serious, life-threatening type of disease, right? Yet, he's not the only person who believes this. There's a lot of people, and you see stories on the news fairly frequently of people who will forego conventional medical treatment, which is evidence-based, based in research, based on trials, all these sorts of things, and instead go for what we would call an alternative route, alternative medicine or alternative therapies or whatever you want to say. Dr. Barry Castleth, chief of Memorial Sloan Kettering Cancer Center's Integrative Medicine Department, was a little more harsh. She says, Jobs' faith in alternative medicine likely cost him his life. He had the only kind of pancreatic cancer that is treatable and curable. He essentially committed suicide by refusing to take the particular treatment. So at this point, you can look at him and say, well, that was pretty dumb of you. You should have listened to your doctor or whatever. It's easy to go back. But the truth of the matter is that all of us see, and this is like conflicting signals, right? We get conflicting messages, conflicting information. One source says, go to your doctor, get your science-based treatment and get the drugs, get the surgery, get the radiation, whatever it is, and that's the way to go. And another source will tell you, no, that's only going to make you suffer. All you need to do is eat the right diet and get a lot of fresh air and get a lot of sleep, and that will cure your cancer, right? And these are two very conflicting messages. And as individuals in society, it can be often quite difficult to pick out which of these messages we should be listening to, right? You could be an expert in one of these areas and know very well why one of those is a good option and one isn't. But for many of us, it's not quite so straightforward. The other thing that's happening in the background behind all of this, and it's been very obvious for me in the last 4 years, looking downwards at the US, is there's been a public erosion, or like an erosion of public trust in experts. Where I think maybe if you went back 30 years, the doctor tells you to do this, you do it. Like, you just believe your doctor. For good or bad, because I'm sure there's some negatives as well. But there's a large amount of distrust of experts, and what's even scarier is a distrust of evidence and facts, where people are saying, well, you can't trust information, you can't trust data, you can't trust anything that's published because it doesn't fit in with what somebody might want to believe. So obviously, there's very real life consequences for choosing to believe in the wrong information, like is what happened to Steve Jobs. And I'm hoping, one of my kind of messages in this course and one of my goals is to help people understand how to choose the correct sources and how to know who to trust and when to trust. And I'm not saying just trust me, right? Because I'm not an expert in any of these areas that I'm talking about. I'm an expert in organic photochemistry, which probably won't apply to anybody here in this room. But I know enough about enough of these topics that I can at least hopefully put you on a good path for most of these things. So this is really the truth, If you happen to have credentials and expertise, society/media doesn't necessarily want to hear from you. And somebody who's either famous, like a celebrity, or, better looking, or whatever the question might be, gets a lot more attention and gets a, as you can see here, a much larger megaphone to spread your message. And this can have very negative consequences on us, especially now with social media making it very, very easy for anybody to spread their opinion with no sort of editorial process, which was always in place for published materials like newspapers and magazines. Anyone can just kind of say anything. And if it's somebody who has a lot of followers, then a lot of people could believe that. So here's an example. I'm going to pick on Katy Perry for a second. This was a post she put on Twitter back in 2013. So this is quite a while ago, where she says, "I'm all about that supplement and vitamin life." And she's holding up bags, and if you can look closely at the words on the bags, you know, the one in front says dinner, the one behind it says breakfast. And what it is just full of pills. And all these pills would be supplements. Like there might be a, I don't know, powdered collagen. There might be an iron supplement. There might be, and so what she's advocating is like a lifestyle where most, or at least some of your nutritional needs are not necessarily met by eating a healthy, balanced diet, but instead by taking supplements. And she has a lot of followers, 107 million as of 2019, last May. So that's a lot of people who will see this and think, oh God, if Katy Perry's done it, she looks beautiful and she looks young and vibrant, energy, you know, maybe I should adopt this same lifestyle. Where Katy Perry is hardly, you know, she's a great entertainer, but she's hardly somebody you should be looking for medical advice or advice about your own health. Just to put this number in perspective, 107 million, like Health Canada, who I keep, you know, plugging for them, 229,000, FDA, 240,000, European Food Safety, 29.4. World Health Organization is a bit better, but they're still less than 5% of what Katy Perry has as an individual. So in terms of these big organizations, which are by and large putting out very trustworthy guidance and evidence-based, science-based guidance, the number of people that they can simply reach with this message is just much lower, just by sheer numbers of followers, than what many other people are able to command. Gwyneth Paltrow was another one that we like to pick on now and then. She has a brand called Goop, which is like a website where you can go and you can buy all sorts of nutritional, health, lifestyle, and cosmetics, and all these other types of products, which a lot of them are very fringe and very wacky and very, in some cases, very dangerous. So this store expanded to Canada. This is back in 2018. Some of it contains very dangerous sort of medical advice. I believe she now has a show on Netflix called Goop, which is basically like a, you know, I've actually never watched it, so I don't even know what it's like, but I assume it's in the same vein as her brand. Some of the things they sell on this site are just sort of like funny. Like this one is a psychic vampire repellent protection mist that you could buy. Nothing on this page is cheap, $38, but some of it is actually very dangerous, and this was one of her things that made the news quite a bit. It's called a jade egg. And the idea is women should buy jade eggs and insert these into their vaginas and leave them there all day long. And so this is the advice or the theory behind this particular item. And that could be potentially a very dangerous thing for people to be doing. Why would you ever want to do this? And the idea is oh, well, it'll bring, you know, it'll help you relieve your stress and bring clarity and all these sorts of intangible benefits that are, you know, would be very difficult to measure. But the danger is very real. In fact, they were fined $145,000 for the claims that they were making about doing this. Didn't stop them from selling them. You can still actually buy it. I think, actually, I haven't gone on anytime recently, but I think maybe you can still buy these jade eggs. Don't buy these. They are, to say it's unnecessary is an understatement. They're much more than unnecessary. They're dangerous. But I see this all the time. And like, it's been a long time since I've been on a plane, the pandemic and everything like that. But I always find it very entertaining when you fly internationally and you get those Sky Mall books, you know, the ads. because so many of the products in those SkyMall things are so ridiculous. Like, it's so much worse than just like a regular catalog, or, you know, I don't know who's buying these things, and if you'd like to buy these things, no offense intended. But yeah, this was one of the ones that I've seen in that, where it's saying, is your throat still living in the 20th century? What's in the water you're drinking, or what's missing? Today, people drink water that has a hydrogen bond angle of 104 degrees. They need to be drinking water with a bond angle of 114 degrees. Call us for a free sample of our water. So, looking at this as a chemist, like, I don't think you could put a more ridiculous statement on an advertisement than something like this. Water is water, and water is the shape it is and the size and whatever else it is due to fundamental physical properties or physical principles that we have no control over, and you can't change the bond angle of water. And we're not drinking water with a bond angle of 104 degrees. None of this is true. But if you didn't know that, if you didn't study any chemistry or anything like that, you might read that and like, oh geez, am I drinking water with the wrong bond angle? I guess they're counting on people to think that way in order to sell their product, or why else would it be on the ad? Right? Like, it doesn't make sense to me, but yeah, there are people that this would appeal to and then would therefore make a purchase. So this is what I would call an example of pseudoscience, where something kind of appears to sound scientific or real, or like a real thing you need to be concerned about, where in reality it's definitely not. And what we really want to do is discuss in this unit what makes something science versus what makes something pseudoscience. How can you tell them apart? And what are the sort of flags that we should be looking for? So what is science? And I really don't want to belabor this point too much, because I think you start learning about the scientific method in, I don't know, grade 3 or something like that. And you probably have seen observations, conclusions, hypothesis, experiment, all these sorts of things again and again. One thing that I just wanted to mention is that in this picture, you can see it's a circle with arrows. What I like about that image is it shows that this is not like a start here, end here type of process. This goes again and again and again. It kind of almost never stops. We're always learning new things, gathering more evidence. Our understanding of science is always evolving. We're constantly finding things we once believed to be incorrect, or maybe not fully, completely understood, and then we correct them and flesh this out. So it's constantly happening and growing. It's not like a place and stops in one place. Claims, scientific claims, they come from observations that are hopefully objective. And objective means that you didn't cloud your observation with what you were hoping to see, or you only included the observations that verify what you're trying to say, and you ignored other things you observed. So they have to be objective. It involves experiments that are repeatable, meaning you do an experiment and you find X. Somebody else could redo that experiment in some other part of the world and also get X, right? Statistics comes into play a little bit. Science makes definite predictions. So we would predict if you threw a ball out the window, it's going to land here. It can make definite predictions, or else it's not science. And in principle, be refutable. So what that means is you can make a claim which could then later be shown to be incorrect, right? So like if I told you, let's say I was going to give an explanation of why something was the case. Like, why does something fall to the ground? And I said, well, the God of thunder makes it fall to the ground. And then next time something different happens, you can say, well, the God of the thunder just didn't feel like it today, or whatever. Like, that's a really bad example. But you know what I mean. If you have an explanation for something which then doesn't predict something else down the road, it's not really a scientific explanation. Pseudoscience, on the other hand, a little bit more vague, I guess. And I put a lot of thought into what I think pseudoscience is, and I think it's a couple of things. I think pseudoscience can include claims that are not supported by evidence. So just claiming something that has no scientific basis. Like, I'll talk about this later, Donald Trump claiming that hydroxychloroquine is a treatment for COVID-19. when there's no evidence to show that's the case. That's one branch of pseudoscience. The other side is claims presented as if they were supported by evidence. And there's a slight difference there that we'll get into. The good thing about claims that have no evidence to support them is you can get that evidence. You can test those sorts of claims. And after they're tested, it either becomes science or remains pseudoscience. But you can learn about things that are evidence-free. You can go get that evidence, potentially. An example of this, a very interesting and neat example about this, comes from the world of traditional Chinese medicine. So traditional Chinese medicine is medicine practiced in China for thousands of years. And this is a traditional knowledge, and it's used to treat all sorts of potential medical conditions. This body of knowledge, by and large, is not tested using our scientific method. It has not gone through double-blind, clinical trials, all these kinds of things that we do to do testing of how things might impact our health. By and large, traditional Chinese medicine is outside of that, although some increasingly is being tested. And the pharmaceutical chemist named Tu Youyou was very interested in looking at potential cures for malaria. And these were cures for malaria that were supposedly going to come from some traditional Chinese medicine sources. So what she did is she investigated, she looked for traditional Chinese recipes for cures to help treat malaria. And what she found was like hundreds of different recipes, variations on the theme. And she found roughly half of them contained an extract from the same plant. And that plant is shown in this picture. It's called sweet wormwood. And there were teas, or it was baked into foods or soups or whatever it was. And she saw this plant again and again and again cropping up in these malaria treatments. And so what she did is she set to work to see if there was maybe actually some compound in there that worked as an anti-malarial drug. And she worked and worked and worked. She tried a bunch of different recipes. And in vitro, which means in glass, in petri dishes, nothing was having any effect. Until eventually she found a small percentage, I don't know what the percentage was, 5%, whatever it was, of the recipes that she was studying and working from made teas using cold water. So this is actually a kind of a new fad now in coffee. You soak coffee in cold water and you leave it overnight. And I've actually never tried that, but the idea is you can make a tea with cold water by leaving this in for a long time. And what she found is that if you do that with this plant, you do extract a chemical that's not there if you use hot water. And the chemical is called Artemisinin. Artemisinin, I'm not sure if I'm pronouncing it correctly. And this compound decomposes if you heat it up too much. So it's a very delicate compound. So if you use hot water like we would normally use to make tea, this gets destroyed. And she found that in petri dishes, this compound was extremely effective against malaria. And what they were then able to do is find ways of making this on a large scale. And this is now the #1 treatment for malaria worldwide, believed to have saved, I don't know how many thousands or millions of lives. And she ended up winning the Nobel Prize in Physiology and Medicine in 2015, which to me is actually a really nice example of translation of traditional knowledge, which was by and large, there was hundreds and hundreds and hundreds of recipes, but of those, there was some good information, right? Obviously, a lot of them didn't do anything. A lot of them were not effective. If you use the same recipe with hot water, it would be not effective. But some were effective, and from that, they were able to develop a frontline drug. And so this is applying the scientific method to that area of traditional Chinese medicine and yielding very good results for the benefit of humankind. There's the flip side of that coin too, right? Traditional medicines, there are some diamonds in the rough, if you know what I mean. There are some very potentially valuable types of medicines that come from traditional knowledge for sure. But there's also some very negative side effects that can come from traditional medicine as well. One of these is the idea that rhino horns can be used to cure cancer. And I believe in some places they believe it also will cure male impotence. And if that's the case, what this has done is created a huge market for sort of black market horns from rhinos, which has devastated their species. So you're hearing these species that might have like handfuls of individuals left, or like certain subpopulations that are going completely extinct because of poaching. And what's driving this whole thing is this unfounded belief that there's medical properties to some of the parts of these animals. And you see the same thing, not just with rhinos, but lots of other animals as well. There's a belief in some cultures that tiger penises can be dried and powdered, and that will cause or help male virility somehow, which definitely, I don't know if that's even been tested scientifically, but it's not true, right? There's no evidence, at least, to support that that is true. And here's Trump. Many doctors think is extremely successful, talking about hydroxychloroquine. And some people don't. As you know, I took it for a 14-day period, and I'm here. So, you know, this isn't just his only statement on hydroxychloroquine. He said many, many statements in favor, like, he was trying to downplay the severity of the epidemic by saying, oh, we got a cure for it. You don't have to worry about it. Use hydroxychloroquine. And Fauci, who's a medical doctor, said, if you look at the scientific data and the evidence, the scientific data on trials that are valid, that were randomized and controlled in the proper way, all of those trials show consistently that hydroxychloroquine is not effective in the treatment of coronavirus disease or COVID-19. The evidence just wasn't there. So these are claims that are being made without evidence, which you can test. And in the case of the sweet wormwood, then, you know, the good stuff was able to be pulled out through the scientific method, and the benefit was able to be amplified. And in the case of hydroxychloroquine, the scientific method showed this is a dead end. We should be looking at other potential treatments or vaccines or whatever you have. What was the response to this? Well, I don't know how closely you followed things up the final days of the Trump administration, but maybe you have rallies where everyone was chanting, "Fire Fauci," because he was saying things that didn't echo what Trump was saying, because Fauci was saying things that were actually evidence-based, which is not the message that Trump, of course, wanted to get across. First question of this unit. Chinese pharmaceutical chemist Tu Youyou received the Nobel Prize in Physiology and Medicine in 2015 for isolating an unusual compound called Artemisinin. Artemisinin? I don't know. From the sweet wormwood plant. Why is this substance so noteworthy? It's a traditional medicine found scientifically to be effective versus malaria. It's the first substance found to be non-toxic at every possible dose. You know that's not true, right? Hopefully. It's traditional medicine found scientifically to be effective versus leukemia. It's actually the most acutely toxic substance known to date. So hopefully you can get that one okay. D is not the correct answer. What is the most acutely toxic substance known? Yeah? Botox. Yeah, Botox. Number one for right now, at least. There might be worse. We just haven't met it yet. Question 2. What COVID treatment was highly touted by former President of the United States, Donald Trump, despite no evidence that it was effective? Thimerosal, Artemisinin, Theobromine, hydroxychloroquine. This one should be pretty straightforward as well. Yeah. So we kind of covered claims that people make, and there's just no evidence to make that claim, and how we address that. We test them, right? We find that evidence and then either accept or reject that claim. So to me, those are the sort of the less dangerous types of pseudoscience. And it's not even really pseudoscience, it's more sort of incomplete science. It's claims that are being made where we may not have enough to know that yet. claims presented as if they were supported with evidence is a little bit more insidious, if you know what I mean. Here's an example. The sun is the main driver of climate change, not you, not CO2. Earth to Scale, friendsofscience.org. First of all, they're presenting themselves as having scientific credibility by calling themselves friendsofscience.org. And this is something that you see a lot. There are people who are putting forth claims that are what I would call pseudoscientific, unsupported, will often try to cloak their message in a semblance of sort of scientific credibility. So making it look in some way as if it's scientifically credible, which for the average person, it can be very difficult to distinguish from an actual evidence-based, scientifically founded claim. This was in Calgary, by the way, and it was this Friends of Science, they're not Friends of Science, they are Friends of the oil industry, and they were promoting this message so there would be no public support for further restrictions on oil and gas and CO2 production and so on, because that would hurt that industry. That's why that message was put out there. Yeah, this has been measured. We know the claim, by the way, here is that it's the sun, fluctuations in the sun that's causing warming of the earth. And this has been studied and it's well understood to be not the case. Dr. Oz is, I think this is the last example I'm going to talk about today. He is another great example of this. Someone who, on the surface, has a lot of scientific credibility. He's a medical doctor. He's a cardiologist. He has a medical degree. He practices in an evidence-based discipline. He is, board certified. He, up to a certain point at least, held a professorship in a medical department at a university. So on the surface, he has all these sort of credentials that makes him seem like an authority, a scientific authority. Yet he also has this TV show where his character on the show is a medical doctor, and he's always giving medical advice. Like, that's the whole show, if you've ever seen it before. In 2004, a study actually came out where people watched the show, a group of doctors watched the show and took every claim that he made in the show and fact-checked it to see if it was either supported by evidence, unsupported by evidence, or contrary to the evidence, meaning it was the opposite of what we knew to be true. And it turns out about 46% of what he said was supported by evidence. And it goes on to say that the vast majority of the supported statements had to do around diet and exercise, that you should eat a balanced diet, that you should get a lot of exercise, and those sorts of statements. 15% of the advice he gave was against what the evidence would suggest, and 39% was just a claim that was made without any evidence at all. Which, if you put those two categories together, that's over half. You could say most of the evidence given on this show is not trustworthy for either lack of evidence or contrary to evidence. So in particular, he had this one show where he had a member of the show come on and he was talking about green coffee bean extract. Green coffee bean is just a coffee bean that hasn't been roasted, and you can make an extract by soaking it in hot water. And then if you drink the extract, or you could boil the water off and take the powder's remains and put it in a pill. But he was claiming that this extract from the green coffee beans would help people lose weight. And ads with his picture on it went all over the internet. Last night, Dr. Oz spoke about green coffee beans and how they can help you lose weight. And, he has millions of viewers watching this show. And of course, what do you think happened? Everybody who wanted to lose weight, which would be a large chunk of his target population, rushed to find a place where they could buy this stuff because Dr. Oz, who's a doctor, told me this is going to make me lose weight. It turns out it doesn't make you lose weight. And in fact, he was held, I think it was 2016, he was pulled in front of the US Senate. They had a special meeting on consumer protection. And they brought him forward and asked him about some of the claims he was making on his show. And Senator McCaskill said, the scientific community is almost monolithic against you in terms of the efficacies of the 3 products that you call miracles. So he was calling this a miracle cure. He was calling the green coffee bean extract a miracle weight loss supplement. And Dr. Oz says, I actually do personally believe in the items I talk about on the show. I passionately study them. I recognize they don't have the scientific muster to present as fact. Which begs the question, well, why are you pushing them on your show? Well, the answer to that is obvious, because he gets a big cut for every bottle of this that gets sold. There's a huge financial incentive for him to promote products with his picture on them because they'll sell out. It's like the Oprah Winfrey book club effect, that when she had her show, I don't know how long ago it was canceled, but she would have like the book club, and she'd have, I don't know, it was a new book every month. As soon as that came on her show, the book was released, thousands of copies of that book would just start to sell because someone with a large megaphone starting to support that particular thing. Now, supporting a book is a very different thing to me than selling an unproven weight loss product. It turns out that they had to actually repay. They were charged $9 million in a lawsuit that had to go back to customers who had paid for this product because it doesn't work. You can't drink coffee bean extract and have any clinical effect on your body weight. Who fraudulently advertised green tea extract as an effective weight loss supplement on their TV show? This is a pretty easy one after just seeing that. All right, I think I promised that this is going to be it for today. We'll pick this thing up on Monday, where we want to look at the intersection of these 2 areas, which is claims made with weak or distorted evidence, where maybe like there's a half-truth in what's being claimed, it's like a little bit being twisted or stretched. And to me, this is the most common type of claim that's made, and this is the type of claim which is most difficult to refute, or most difficult to determine if this is a real claim or not. So I'm going to pause it here. We'll have everyone back on Tuesday, and we'll pick things up from where they are. So thanks everybody for coming today. Thank you everybody who is joining us online. I wonder if I type a comment in the chat, if there's a delay on my comment. No, so the comment's immediate, so I can comment on something. Anyway, if you're online, you can look out for that. The quiz says green tea extract. The slides say green coffee bean. That's my mistake. It does say green tea extract. It's supposed to be coffee. Coffee was the thing that was on the TV show, at least. Green tea, yeah, it's probably the exact same thing, just a different angle. I'll fix that online. Thank you, everyone, and we'll see you later.